Okay, so now we are going to condense. So we're going to take this 1/2 and put it back there as an exponent. So natural log of x to the 1/2 minus natural log of y. Now that 1/2, we want to go ahead and convert that to a radical. So that's going to turn that into the natural log of the square root of x minus natural log of y. And then the subtraction between the natural logs is going to tell us to form a quotient. So now we're going to have the natural log of the square root of x divided by y. And there you go, that's it. Okay, 74 has a little bit more going on. We have a 4 out in front that we'll have to take care of, but first we should go ahead and condense this. And then we have this 2 out in front that we'll move back here. So we'll go ahead and take care of a couple of these things at once. So we're going to leave the 4 there for a moment, and we're going to bring this together as the natural log of z times z plus 5. Okay. Then over here, we're going to have the natural log, and I can go ahead and bring that 2 back right now. I could wait, but I'll go ahead and do it now. Now it's time we can move that 4 back. And so that 4 is going to go here. And that 4 is actually going to apply to both parts in a minute. So we're going to have natural log of z times z plus 5, all raised to the power 4. And actually, we could leave it like that if we want. We don't actually have to go ahead and distribute it to both of those bases. And then let's see, then we still have our natural log of z minus 5 squared. And so the last thing we want to do is bring this together as a quotient, just like the previous one. So our final result is natural log, and so the top's got quite a bit going on. We got z times z plus 5, all raised to a power of 4. Like I said, you could actually put the 4 on both of these individually if you want to, but it's fine just to leave it like that. And then on bottom we have z minus 5, all raised to a power of 2 right there. And there you go. Okay, so this next part we are actually solving. Oops, let's too far. We're going to solve these by using the one-to-one property. And so the one-to-one property is basically you need to get the same bases. And if you have common bases, then you can just set the exponents equal to each other. So on this first one right here, we're going to change that 64 to a base 2. So we're going to change it to 2 to the power of 6. It's the same thing as 64. So the one-to-one property is basically if you have the same base, you can go ahead and cancel those out and set the exponents equal to each other. And then from here, it should just be some basic algebra. So we'll go ahead and add 2. Now we've got 4x equals 8. Divide by 4 on both sides. We get x equals 2. And there you go. All right, the next one requires a little bit more manipulation. What we're going to have to do here is adjust both bases. So right here, we're going to write this as 3 squared, but then it still has that other exponent, x plus 2. And then 27, we're going to write that as 3 cubed, and then you have the negative x up there. Okay, so on your power to a power rule, you can go ahead and multiply them together. So this first one's going to become 3 raised to the 2x plus 4. And then the other one, when you multiply that together, you're going to get 3 raised to the negative 3x. Negative 3x. Okay. Now you have those common bases, so we cancel them out. And then once again, we're just put it over here so you can see all this. We just have a pretty simple equation to solve it. Shouldn't give us too much trouble. So some people might approach this differently. I'm going to go ahead and subtract 2x from both sides. So 4 equals negative 5x. Then we'll divide by negative 5 on both sides. And there's your answer. X equals negative 4/5. So I moved the negative up. It's just personal preference right there. Okay, so up to this point, everything has been non-calculator. So even on this, you're going to be asked to do it without a calculator. Because if you did have one, there are ways of kind of getting around this and coming up with your results. But this next part, you can use a calculator. I'm going to go ahead and ask you to just go ahead and give me your exact answers in log or natural log form. If you give me an exact answer, that it'll be okay, but I'm not requiring that you do that. Okay, so the way you want to solve these is you basically need to isolate the base first. And so the problem on this first one is that 4 is not part of the base. The base is the value that has the exponent. And so that exponent doesn't actually apply to the 4. So I'm going to start by dividing both sides by 4. So I get e to the power of x equals 61 over 4. And then now what I'm going to do is you take the log of wherever the base is of both sides. So it's natural log because that's base e. So I'm going to take the natural log of both sides. So on the left side, what happens is if the log base is the same of what you're evaluating, it just simplifies into the exponent. So the idea of this is basically we're trying to get rid of our exponents. And so that's what this does for us. So now I have x equals natural log of 61 over 4. And we can just leave it like that. If you really want to, you could put it in the calculator and get a decimal. But we'll just go ahead and leave it just like that. All right. On the next one, what we're going to do is we're going to take log base 6 of both sides because my base is 6 here. I don't have to do any adjustments to begin like I did on the previous one where I had to divide by 4. I should be good to go. So I'm going to start by taking log base 6 of both sides. Okay, so on the right side, this is just going to reduce, I'm sorry, the left side is just going to reduce down to that x plus 2. And the right side, I can just leave it like this. This is fine. And so the last thing you want to do is go ahead and subtract 2. Now, a common mistake is students will subtract the 2 from the value being evaluated. You actually want to make that separate. So we'll make that separate. That cancels out. So we're left with x equals log base 6 of 211 minus 2. And that answer is fine. Now, if you are going to try to give an exact answer and you don't have a fancy calculator, you'll have to do the change of base formula. And so you'd have to take like log of 211 over log of 6 and then subtract the 2. And that would give you an exact answer right there. All right, that's the end of page 3.